All right, so last class we left off with converting angles from degrees to radians, radians to degrees. And so we're still in 5.1, and we are looking at, or starting with coterminal.
Can I ask a question about that real quick?
Uh-huh.
All right, so I did the 5.1 homework.
Uh-huh.
And so question 9 was degrees to radians, 55 degrees, give the answer. But then there was another question that was negative 66 degrees.
Mm-hmm.
And so working through it, the first one that was a positive degree, I got it real quick. It's just, one, is there a trick to doing that, or just for the simplifying, just your best guess and keep simplifying until you're frustrated and can't anymore? And for the negative one, why did it make me multiply by pi to get the proper answer?
Okay, let me make sure I got the direction straight. Now, did it say that your final answer has to be a positive angle? As a matter of fact, let me just let me open it up in my math lab real quick.
No, because the answer was negative. But
okay.
It's
So let me open it up, and I'm gonna share the screen so that everyone can see your problem. You said number 9.
Yeah, number 9 was the positive degree.
Okay, 55. You said that one was fine, correct?
Yeah, that one I just that's just the issue of the easiest way to simplify, and is there a trick to it? I think it was probably number 10 or 11 was the negative one.
Okay, so let me just go there real quick. So we're talking about 55 degrees. We're going to multiply that by pi.
Yep.
Over 180. And so with this one, yeah, it's just all about being comfortable, or how comfortable or familiar you are with those numbers that you see.
Okay.
Of course, if they're more familiar, 4 over 6, easily you see a 2 that's in common with both. But since and with the numbers that we have, they may not be as familiar as other times. So you would start with something that that goes into both, which is 5.
And just that's deducing.
yeah, that's pretty much how you
Okay.
Yeah. Other than that, there's no real trick to it. Just familiar numbers versus unfamiliar numbers.
Okay.
Yep. Okay, so let's go to, let me stop the share completely. But the next one, you said 10 or 11?
No.
11, okay.
Okay,
Negative
yeah,
62.
so this one.
Oh, well, it says round to 2 decimal places.
Yeah.
So with that being said, hitting the wrong button. I know y'all can hear. So we're gonna still multiply that by pi over 180. And since it said round to 2 decimal places,
yeah,
you don't have to worry about any type of reducing or anything at all. You can just multiply across 62 times pi. Hold on 1 second.
So is that just inherently, because it says round to the nearest decimal, that you multiply by pi? Like
Yes. Well, see,
something
that
you should
pi,
know to do?
that symbol represents 3.1415, blah, 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 on to infinity.
Right.
So if you can leave the symbol there as an exact answer, then you don't mess with pi. But since it's set round to 2 decimal places in the directions,
Okay.
you go ahead and convert that to a decimal and then multiply 62 times that
Okay.
pi.
So it's not if it's negative or positive, it's what the directions tell you as
It,
far as the answer.
exactly.
Okay.
Exactly.
See all these tricky little things you know.
So, oh, and also this, let's say if you have the type of calculator that you can't just put it in there, you have to do it in steps. 194.7787. I would at least take that out to 4 decimal places and then round it to the 2 decimal places once you're finally done.
Yeah. Okay.
Yeah, so we should have 1.08. All right. Anything else before we get into coterminal? Good.
This is you assigned homework from that.
Oh, I hear a faint voice. Can you say something? Hello?
Hang on.
I cut my volume up. Did somebody ask me about homework? No?
Somebody said something about assigning homework, but
I thought I heard something.
Yeah, that was me. I'm
Okay.
trying to. There we go.
Okay.
Where do we go for homework and such?
It is mymathlab.com. I'll type it in the chat. You should have gotten an email with that information. If not, it's in Canvas under announcements as well.
Okay.
And you have to go there and register. Then we have a course ID. I will find it for you before we leave. I got it in my paperwork over here, but the course ID is also, like I said, in Canvas, and it should be in an email. But if you signed up late for the course, you might not have gotten that email, but it is in Canvas under your announcements. So, all right. So let's look at coterminal angles. All right. So coterminal angles, 2 angles with the same initial and terminal sides, but possibly different rotations. So that means it could go positive or negative. So here's an example of 2 coterminal angles. Notice our initial side. Initial side is down here. Terminal side is up here. So in our first one, 30 degrees. Second one, we're going one full rotation and then the extra 30 degrees. So that's how we got 390 degrees. So that would be two examples of coterminal angles. All right, scrolling up a little. Not intervals, what's the word? Multiples, that's what I'm looking for. Okay, so we will be able to find coterminal angles by either adding or subtracting multiples of 360, or if you're in radians, we're talking about 2 pi. So directions could say find. Okay, so directions could read find a positive angle less than 300 degrees that is coterminal. So there are infinite amount of positive and negative coterminal angles, but always make sure you watch those directions. Find a positive angle less than 360 degrees that is coterminal. So look at first one is 420 degrees. So if I want an angle that's coterminal to that, remember we want it to be less than 360 degrees. So we would subtract. And that's it. All right. Next one, negative 120 degrees. So not only do we want it to be less than 360, but we want it to be positive. So in this case, we're going to add 360 to that negative 120. $240 degrees. All right, questions. Next one. Oh yeah, go ahead.
360 is the default number we would use for these equations?
Yes.
Okay.
Yes. And then like we're doing in the next one, it would be 2 pi for your radians.
Okay.
So let's look at, here we go, 17 pi over 6. So we're going to do the same thing for 17 pi over 6, but because we're in radians, we're going to use 2 pi. So we have to be careful here because we want to make sure that since we have a fraction, we want everything to stay exact. Just like your classmate brought up the example with the direction saying round to 2 decimal places. If it does not say round to 2 decimal places, they are assuming that you're going to stay exact unless said otherwise. So we need to make sure we use our fraction skills of adding and subtracting. So don't forget, if you're going to add or subtract fractions, you have to have a common denominator. If I'm going to subtract 2 pi, initially the denominator will be 1. I wanted to have the denominator of 6 in order to subtract it from 17 pi over 6. So I will multiply both top and bottom by 6. Don't forget, whatever you do to the bottom, you have to do to the top. So that's 17 pi over 6 minus 12 pi over 6. Now we can do our subtraction. That's 5 pi over 6. All right, questions? Any questions on that one before we look at least one more? All right. Throw a negative in there. Negative pi over 12. So same type of deal. You have negative pi over 12. Want it to be positive and less than 360 or less than 2 pi. So we will be looking to add 2 pi. This time the denominator that I need is 12. So I'll multiply 12 to the top and bottom. Negative pi over 12 plus 24 pi over 12. Add them together and we have 23 pi over 12. All right, one more thing before we leave 5.1 and jump into 5.2. Let's go with
The question, sir.
Yep.
So so you could just leave it like this. When would you know that you have to break that down?
You're talking about when you say break it down, you're talking break it down to a decimal or just simplify it as a fraction?
Simplify. Is it going to specifically tell you that, or?
No, they're going to expect you to do that.
Okay.
They're going to expect you to know that they want the answer in its simplest form.
Okay. So
yeah.
for homework, this wouldn't be acceptable for my math lab.
You're talking about 23 pi over 12?
Yeah.
No, that one would be fine. Now let's say if it was 14 pi over 12, that answer wouldn't be acceptable because the 2 can cancel out. 7 pi over 6 would be the acceptable answer here. Here.
So, all right. So essentially, it's just the divisibility thing.
You said say that one more time. It's a divisibility thing.
So yeah, it's a divisibility thing.
Oh, so divisible. Yeah, right. Can 2 divide? Or do they have a common number that can divide into both of them evenly?
Yeah, because so pre-calc 1, the dude was doing some weird things with random numbers coming up with stuff. And I was like, that doesn't even look like it makes sense. You know?
Right.
Like the top would be 5 times 40 and the bottom would be 3 times 60.
And that's how it just didn't make any
What
sense.
the world?
Yeah, it's some old world math. I don't know.
Oh, wow. That was
Yeah.
at TCC?
Yeah.
Oh, okay. Well, I won't ask you who it was. Wow. Okay. All right. Well, yeah.
So,
Not sure where that was going.
yeah, that's what confuses me the most on these is it's fairly simple practices. Just when do you keep going or when do you just stop? You know?
Right, right. So in these cases, you're right. It's a divisibility thing. If the bottom number, just like if we ended with 24 pi over 12, then that reduces down to 2 pi,
Okay.
and that's the answer that they would be looking for.
Okay.
So yeah, that's all about. Do you have anything in common that they both can divide? They can both can be divided by evenly, and yeah.
All right.
And if you see anything that challenges that, let me know so we can make sure that we, just like you did today, make sure, we get you straight as far as these directions are concerned.
Okay.
All right. Sounds good. Let's look at length arc. So it's the length of a circular arc. So non-negative. All right. So the length of a circular arc. We want to let r be the radius of circle and theta be the non-negative radian measure. So that's going to be key. Make sure your theta is in radian measure. And I left out the A. So radian measure. It's possible they could give it to you in degrees and ask you for the answer, and they're going to assume you know to convert it to radians. So it should be in radian measure if you're going to use this formula of a central angle of a circle. The length of the arc intercepted by the central angle is my black marker back. All right, so it's just S equal to R times theta. I think, did we do? Oh, we did the other one. Okay. All right. So let's look at an example. Yep. Somebody asked about S. S is the arc length. Yes, these are the same variables from last formula. Yep. S being arc length, R being radius, theta being your angle, central angle. So, and thank you for, I didn't see the name, but for typing that in there. Okay, so just a mini example. A circle has a radius of 10 inches. Find the length of the arc intercepted by a central angle of 120 degrees. All right, so R is equal to 10. Then we have our theta, which is 120 degrees. But we just mentioned that, remember, if we're going to use this formula, theta has to be in radians. All right. We're going to multiply our pi over 180. As far as this breaking down, 60. 60s cancel. Leaving us with 2 pi over 3. Let's see, did they ask for? Yeah, they did. Okay. So now the formula. So just writing that there. All right, so we got R, which is 10 times 2 pi R. I guess we didn't have to write the radians part. And in the book, they gave us 20.94. My math lab will let you know which one they want from you. So just make sure you watch those directions.
Excuse me.
Yep.
Is this a part of 5.1 or is this a part of 5.2?
Still 5.1.
Okay.
Yep.
Thanks.
No problem. They have a few other formulas in there, but I don't remember seeing those in my math lab. So I will, this is what I'll do. We'll go ahead and start 5.2. I'm going to check the homework in my math lab and see if the other formulas are even touched on. And then we'll go from there. So let's go ahead to 5.2. Questions on this before we get into 5-2, right triangle trig.
The last question
Mm-hmm.
of homework was talking about converting the angle from degrees to, I think that's minutes and second form.
Minutes and seconds. Let me see if my stuff is still up. Coterminal, that was 20. Let me see 21. 20 degrees. All right, hold on. What? Hit the wrong button. So yeah, it should be. Yeah, I think I see it. I wonder why they put that one in there like that. Because they didn't even put it in the book. Oh, okay. So they didn't even. Okay. Well, we can talk about it. Looking at the technology thing, they didn't even tell you how to do it. They just said put it in your calculator. Okay.
Which is a whole nother lesson in itself on how to use this.
Oh, okay, let me make sure I remember how to do this one because I didn't even know they put one like in it. It's multiplied by 60. Let me divide it. Yeah, that don't make sense. Why would I do it that way? Okay, hold on 1 second. Times. That's not making sense. 0.26. No. Times. Right, so 0.25 times 60. Right, and that's 15. So, all right, let me make sure I got that. So they say don't feel bad when, well, in my defense, yeah, but 53 to 0.26 is really something that we went through a long time ago. There we go. All right, so 0.26. That's what I did the first time. All right, so this thing tripping. Okay, and then 0.6 divided by. Yeah, okay. So what we have to do is take our numbers, and I did that. I don't understand why it didn't work out the first time, but it's all good. And 0.39 divided by 60. And I'm just trying to end this problem, so I'm telling you accurately. All right. So 0.39 times 60. So that should be 23. And then 0.4 times 60. 24. All right. So let's say 54.39. Share. Okay, so the last problem in this section is convert a number to a degree, something that's in all degrees to degrees, minutes, and seconds. So it's all based on 60. So that's why I was trying to figure out, do I multiply, do I divide, and all the good stuff like that. So it's all based on 60. You know, when you talk about your rotation, your clock, 60 minutes, 60 seconds, you know, all the good stuff like that. So you're talking about your full rotation. So it's based on multiplying by 60. So the first part of this is 54 is in degrees. And the way they have it in my math lab, if you haven't seen it yet, they give you 3 boxes. So the circle correlates to degrees. One, I guess apostrophe would be minutes, and then the 2 would be seconds. So the first part is given to you, which is 54. All right. So now to get the minutes, we take 0.39 and multiply it by 60. And that is 23.4. So the 23 is what goes in there for minutes. Then we do 0.4 and multiply that by 60. And that's 24. And that's how you would do that. So like I said, I was just getting my stuff crossed up, and when I divide, multiply, and all stuff like that. So then if you had for some reason to go back the other way, then you would be looking to divide. But this is what they asked of you. Right. Questions on that? So let me do this too. This 0.4 is where that came from. And this 0.39 is where that came from.
What if the number is more than 60? Would you just, like, yeah, I'm just kind of caught on that. What if the number was more than 60?
In your denominator?
Yeah.
I mean, not your denominator, you're talking about after your decimal?
No, before the decimal.
Oh, it still would be the same. Like, you know, you can have 120 degrees, 139 degrees.
Okay.
Yeah, you know, just like, remember our full rotation is 360 degrees. So yeah, you would just put it in a box in the same fashion.
Okay.
Okay, so I do have a question. So I went backwards and I divided. So I took the 0.4.
Yeah.
Divided that by 60. And then I took the 23 and divided that by 60, but it gave me 0.3833333.
0.3833. So you got close.
I got close, but it seems on the lower end. So wouldn't that round down to 38, not 39? And then.
Right. So let me see. 4 divided by 60.
Math.
So now.
Another language.
Right.
Plus. Hold on. Yeah. 0.4 divided by 60 gives me that. And that's plus.
Yeah, I mean, it's close because.
Yeah.
38 times 60 gives you 22.8. So it's like it's off just a bit.
Right.
It's enough to mess your numbers up.
And I think it is because, let me do this, 0.39 times 6. Well, you would have thought 0.4. Okay. Now, your first division of 60, what did you divide that 60 into again?
I did the 24.
Okay.
So
you
yeah,
did,
if you were taking it from the DMS to an angle,
right.
I took the 24, divided that by 60, and got 24, and then I took the 23 and divided that by 60 and got the 38.333.
Okay, hold on 1 second. So now we're supposed to be going backwards. So we're taking the 24, divide that by 60. That would then give me, let me get a good color. Okay. Dividing this 24 by 60 gives me this 0.4. If I take this 0.4, then I add it to the 23.4, and I take that 23.4, divide that by 60, and then that gives me 0.39.
Okay, so when you go backwards,
Mm-hmm.
you essentially got to take that answer, add it to. It's not just individual. You got to.
Right.
Okay.
Yeah.
Okay. See, these are good things to know for tests.
Oh, yeah. All right.
All right.
Sounds good. What time is this class end? I want to jump in here and then 2:45. We can at least introduce it and really get rolling next class on 5.2. So let's introduce 5.2 just in case somebody want to get in there this weekend. So we're looking at right triangle trigonometry. That should be a G. That's that all the way up. Let's see if they give you the inverses. Yeah, I'll just do it that way. All right, so our 6 trig functions: sine, cosine, tan, cosecant, secant, and cotangent. So the reason why I put these arrows going back and forth between sine, cosecant, cosine, secant, tan, cotangent, those are the inverse or inverses of each other. In other words, if you have sine, if you flip the fraction, you will have cosecant. Cosine, flip it, you will have secant. And then if you have tan and you flip that, you have cotangent, and vice versa. So they're inverses of each other. We did go there. Yeah. All right. So one way you can remember your right triangle trig relationships is by SOHCAHTOA. Sine is going to be equal to opposite over hypotenuse. Cosine is going to be equal to adjacent over hypotenuse. tangent will be equal to opposite over adjacent. And then for the other three, like I just mentioned, you would flip them to get the other ones. So your sine will be the inverse of secant. Sine will be inverse of cosecant, cosine inverse of secant, tan inverse of cotangent. All right. All right, so for your right triangle, remember we can never assume that we have a right triangle. There always have to be either be some kind of wording or your square in this box, in this corner to let you know that you have a right triangle. And opposite of that square will always be your hypotenuse. So hypotenuse is always opposite the right angle and is always the longest side in your right triangle. Oh, and just in case, didn't remember geometry, some of those geometry things. Oh, connection, sides, and there goes side relationships. So also, as you're going about doing this, it may help that you hold on to the idea that side relationships correspond to their respective angles. So what that means is that if side A is, you don't use lowercase for the sides. Side A is longer. And side B. So that means if side A is longer than side B, then that means angle A will be larger than angle B. Now, I don't think I drew it on the other triangle, but I'll do it here. I'll go A, B, C. This would be C, this would be A, this would be B. Any questions on anything I've said so far?
Nope.
All right, going back to SOHCAHTOA. Yeah. Someone asked if sine would be equal to 1 over cosecant in the chat, and that would be correct. Yep. All right. So we're looking at sine, like I said, SOHCAHTOA. So sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. And once again, if you flip those, you get your cosecant, hypotenuse over opposite, hypotenuse over adjacent for secant, and adjacent over hypotenuse for cotangent. And before we do this example, can't forget the possibility of the Pythagorean theorem showing up. Right. Oh. All right, so Pythagorean theorem, a squared plus b squared is equal to c squared. C is always your hypotenuse. C is always the hypotenuse. A and B are always legs. And are interchangeable. So A and B can be put in any order, and I didn't say this about C. C is always on one side of the equation by itself. Your hypotenuse is always on one side of the equation by itself. A and B are always legs, and they're always, and they are interchangeable. All right. All right, so find the value of each of the 6 trig functions of theta. And so we have theta down here in the left corner where A is. And so we do need to know or calculate what our hypotenuse is before we start to establish our trig relationships. So we'll go ahead and use the Pythagorean theorem. Don't forget the Pythagorean theorem only holds true for the right triangle, which is what we're dealing with, but just make sure you do have a right triangle. We got A is equal to 5, B 12, and then C is what we do not know. So looking at 5 squared, 12 squared, equal to C squared. 25, 144, C squared. Add them together, give us 169, C squared. Take the square root of both sides, and your square and square root will cancel, leaving us with C equal to 13. So if anybody was questioning possibly the square root property, whenever you take the square root of both sides, you should get 2 answers, plus or minus 13. But don't forget, we're dealing with measurement, and there's no such thing as a negative measurement. So we're not using the negative 13. The only one we have to consider is the positive 13. Okay, so if we go back to our diagram, C is 13. And what is opposite versus adjacent? Now remember, C is your hypotenuse no matter what angle you're dealing with, but what is considered opposite versus what is considered the adjacent side? It all depends on theta. Notice theta is right here. So what is opposite of theta is 5, and what is adjacent to theta is the 12. The numbers would be switched if theta was up top. All right, so we have opposite, adjacent. Oh. Five and 12. All right, so it says sine of theta is opposite over hypotenuse. So we would do 5 over 13. Cosine theta, adjacent over hypotenuse, 12 over 13. Tan theta, opposite over adjacent, 5 over 12. All right. And then the other 3, cosecant is just flipping sign, so that'll be 13 over 5. Secant, 13 over 12, that's flipping cosine. And then cotangent, 12 over 5. All right, questions, concerns, comments, anything before we close out for the day?
All good here.
All right. Sounds good. Sounds good.
Yeah, I got nothing.
All right.
I just need the, what was it? mymathlab.com, and then what was it
Yeah, the course ID.
yeah, there we go.
Yep. So I can give you the first one. It's the first part of it is Tucker. It's my name. And let's see.
Is it capital T?
I don't believe it matters, but I always stick with the lowercase.
Okay.
Yep. Now let me ask you this. Not saying that I'm making you go do it, but just for just informational purposes. Did you check Canvas?
Yes, I checked Canvas, but
Uh-huh.
I don't see anything in my announcements.
Okay. Did you sign on later?
Yeah, I was having issues with classes beforehand.
Yeah, it shouldn't matter. It's supposed to stay in there, but that's why I'm asking, so I'll know what to ask tech support about, and try to figure out why. Because even if you register late, you still should be able to see it. Whatever I put in the announcements. So it's Tucker 84511.
Okay.
All right. Someone also asked about the recording of the lecture. I've not posted them yet. I'm going to generate them probably between today and tomorrow, and then I will shoot you guys links in an email, and then also put them in Canvas under the announcements. So make sure you guys can see the announcements. He just said that he couldn't. I'm not sure if it's a classroom thing or if it's just a late registration thing. Yeah, and it's not supposed to work that way, because once I put it in Canvas, it's supposed to be in there for the whole shell, regardless as to what time you register. So anyway, we'll figure it out. But if you have any questions on anything, then always feel free to ask. It's not a big deal. But I'm just trying to see what I'm working with technology wise. And yep, and I will. No problem. You're welcome. I will, like I said, generate even this lecture right here. I'm gonna generate a link through YouTube and then shoot that to you guys, and you always have access to it. Outside of that, any questions or concerns before we close out? I think most everybody said they're good. All right. So thank you guys for showing up. Have a great weekend. Try this stuff out. Some questions may not pop up until you actually start getting to work. Try the stuff out, and I will see you on Tuesday.